Well, good afternoon, everybody, and welcome along to this month's session of DBA Fundamentals Down Under. For May, we're having a look at the survey of the Azure data landscape with Ike Ellis. Now, I'll hand over to Ike shortly, but before I do, I've just got some housekeeping that we'll run through. So first off, I need to just have a big shout out to our sponsors, SentryOne. Without the sponsor, it makes it difficult for us to put these sessions on for you. If you're not aware of SentryOne, make sure that you go along to their website, have a look at their articles, videos, downloads, etc. that they do have on there for your educational learning. Make sure that you play with those, provide any feedback, and they do provide some fantastic tools to assist you in your SQL Server environments. Now, I just want to make a call out to some upcoming training days. So we've got the Business Analytics Day in June in Atlanta that you can register for. There's also another one in August in San Diego. So if you're interested in going along to those, make sure that you sign up and you'll get some fantastic analytics information from those speakers. Today's session is being recorded, like all of our previous sessions. They will be available approximately about a week after today's session. They will be in the meeting archive section of the DBA Fundamentals website. So if you want to come back and review this, you will be able to see that in about a week's time. Just want to make a call out to some of the, or not some, but to our next SQL Saturday event in this time zone. So in Brisbane at the end of this month, we've got SQL Saturday 6:30. We've also got a PreCon on Zero to Microsoft BI with our fellow MVP Peter Myers. So if you would like to learn some Power BI, make sure that you register for that PreCon. As always, Pass provides a lot of information for us, so stay involved, stay up to date, and if there is other virtual chapters that you would like to learn from, make sure that you register for those, be kept in the loop. Now I'll hand over to Ike for today's session.
Hey guys, can you hear me okay?
We can.
Hey, how firm are we on the hour, by the way? I meant to mention that. Can we go over a little?
We can go over a little.
Okay, I'll do my best. So today you'll look at the agenda and you'll see that we're covering a lot of information, and we really are covering a lot of information. I don't know how many of you here work with Azure frequently, but I work with Azure every day, and when I go into the Azure portal and I see something new every time I go in, I feel like. And the rate of change on Azure is just overwhelming. Things are changing and releasing, and we're going to see even more things release next week when we have the build conference, right? Or is that this week? The days keep going by past me. So we'll see keynotes. We'll talk even more about things that are coming out in Azure. It reminds me of when I was born and raised in San Diego, California, and San Diego doesn't have any mass transit. We just drive our cars everywhere. So I'd never really been in a city that had a train system or that had subways. And one of my very first trips to London, I was 30 years old, and I remember being at Paddington Station and looking up. I don't know if you can relate to this, but it is very overwhelming being in a functioning train station. There are platforms and trains coming in and out and going everywhere, and there are names of cities and times and duration, and I just didn't even know what I was looking at. I just felt like I was completely and utterly overwhelmed. And so I asked some people for help, and they taught me how to read a train schedule, and I, tentatively always wondered if I was on the right train or not. But after about 2 days of doing this, I could not believe how much confidence a functioning mass transit system gave me. I felt like I could go anywhere in the country, and maybe even in the continent, even all over Europe, with just a train pass and a schedule. I just felt so free and liberated. Well, I have felt similar feelings looking at all the different options that I have in Microsoft Azure, particularly as we look at all the different options and where to store data. Like we can store data in DocumentDB or in Data Lake or in Azure SQL Data Warehouse. And why would I choose one of these products over the other? So the purpose of this session is to take those feelings of being overwhelmed with Azure and seeing all these different products and this huge rate of change and calming it a little bit for you. The idea is that I'll just do a quick introduction to the product. I'll tell you what it is and why we would use it. And I would talk about the competitors to this product so that you know what happened on the Amazon side to drive this product forward. Maybe there are other competitors too, like Google Cloud Platform and on-premise competitors. And then I'll have a demo for every one of these products. So we're just going to spend 5 or 10 minutes in each product. So if one product kind of bores you, you can just kind of zone out for a little bit, check Facebook, drift off, and then come back 10 minutes later. You might have a brand new product that you're interested in or that you want to see. So our very first product is called Azure Blob Storage. And this is a place where we store files. And it can be any kind of files. It can be JPEGs or AVIs or PDFs or log files or SQL Server backup files, BAK files, or virtual machine files like VHDs and things like that. And so in Azure Blob Storage, if you look at the left of the slide, we have something called an account. And in this case, I name my account Sally. And then underneath the account, we have containers. And containers are just folders. They are places that we use to organize blobs, the actual files that will get stored. But it's a very flat structure. So unlike our hard drive where we have folders and subfolders and files, in Azure Blob Storage, we just have a very flat listing of containers. And you can name those containers anything you want. Like in this example, we have our pictures in one container and our movies in another. So we're separating the containers by function or by file type. But we could also do it by like application name. We could say, these are the blobs for this application, or these are the blobs for this application. We could also do it by database name if we had pointer records in our database where we were going to go get external files off of those pointer records in SQL Server. We could have a container for each database name or each table name. Maybe we have a lot of different pointers and a lot of different tables, and then we'd have a container for each table. Anyway, just some ideas on how to organize your blobs. And like I said, it's any type of file, and it's highly durable, massively scalable. So I don't know how many of you have worked with SANs before, but when I've worked with SANs, they're great, marvelous things, but sometimes they have some problems. And a couple of the problems are like, one, they fill up, right? The SAN could just completely fill up, and then you say, hey, I need 100 more gigs. And your SAN administrator says, well, that's going to be $20,000 or something like that. Or what I've noticed about SANs is like when the SAN's brand new, that's the fastest it will ever be. And then as time goes on, 3 and 4 years later, it just gets slower and slower and slower. When I tell the SAN vendors this, they laugh at me and tell me that I'm crazy. But I know that this happens with SANs. But with Azure Blob Storage, that doesn't happen. As a matter of fact, Azure Blob Storage is consistent performance. So their SLA is 150 millisecond SLA, but I use Azure Blob Storage all the time, and it's roughly 30, 40 milliseconds for every request. And right now, there's 40 trillion stored objects, and if you double that or triple that, it will always have the same SLA, same speed on the files coming back. It has 3.5 million requests per second, and it's exposed through a REST API. So that means that we have an SDK to use Azure Blob Storage, and we can write code to interact with Azure with .NET or C++ or Java or Node.js or JavaScript. So these prices might be out of date. Don't quote me on the prices, but what I wanted to show you was that you can choose your fault tolerance and scalability. So locally redundant storage has 3 replicas, and it's about $240 for 100 gigs per month. Out of the gate, your files are locally redundant. So you copy them up there, and copies are made so that if anything happens to the servers that they're on or the rack that they're on, they're always available to you. Unless the data center goes down, and if the data center goes down, you can say, oh no, I want my files to be geo-redundant. Or I want them to be geo-redundant but give me read access, so that what you're doing is you're spreading your files all around the world, and then you can have just the, like if you're in Australia, you could have the Australian replica take, or the Pacific replica, serve up the files to your local user, right? Or if you're in Europe, European files to the European user. Now, that still might be too slow, by the way. So Azure has a different service for serving files on a worldwide scale called the CDN service. And the CDN service keeps your files in very fast storage and often in memory. And so it's quite a bit more expensive to do that, but it is lightning fast to do that. It will spread your files up all around the world, and you can just keep them in memory and very quick, but you pay a lot more for that. But it's a totally different service. The Azure CDN can read files out of Blob Storage, that's very easily, but it is a little bit harder to configure. And also, some of the nuance with CDNs are things that get cached, and so you have to expire cache in order for a new file to replace an old file. So there's some complexity in just replacing a file and then making sure everybody can see the new file. Just be aware of that. So like I said, what kind of blobs can you have? We talked about those already. Invoices, contracts, resumes, SQL BAK files. One way that I use Azure Blob Storage is as a backup target for SQL Server. As a consultant, I could go into an organization and I say, hey, how are your backups? And if they don't have a great answer for me, then before I'll work on the server, I'll just back up the databases I'm working on so that I make sure that I've got, I can get back to state 0 if I make a mistake, right? Usually I keep those backups local, but sometimes the local drives don't look like they have enough space, so I'll just back up to Azure. And then the main competitor, Azure Blob Storage, is Amazon S3. Amazon S3, that was the first service that Amazon ever created, and it's still their most popular service. I don't know if you remember, but 2 months ago, S3 went down in the United States, and it brought down like 20% of the internet with it. Like so many services, websites went down when S3 went down. Do you guys know why S3 went down in their retrospective? It's because somebody updated a relational database table. They deleted some records and they didn't check their where clause and they deleted too much. And then it just took way too long for S3 to cycle back up and come back up on its way back up. So yeah, anyway, database related. So that's S3 Blob Storage. And now let's demo it. Let's take a look at Azure Blob Storage. So we're going to look at it in code mostly. And I've got this demo project called Blob Storage that I'm just going to set as my startup project real quick. Oh, let me turn my app off, right click. Okay, and in my blob, I've got this little hello world.png. Can you guys see that okay? I hope you guys can see that. So that little PNG is not in Blob Storage right now. So I'm going to open up my program here and just kind of walk you through a little bit of code. So I've got a breakpoint right at the beginning. So I'll just start my app and we'll just kind of step through. So when you want to connect to Blob Storage, you need two things. You need an account name. In my case, my account name is Data Ike1, and you need a key. Those two things are like the username and password. That's like, I am who I say I am, so please let me interact with my Blob Storage account. So if I go to my Azure portal here, here's my Azure portal. Oh, let's open that up again. Azure portal. Why does this happen? I just checked my internet access and it was working 2 seconds ago. And for whatever reason, my internet, this happened to me the other day too. And I'm not sure why my internet access kind of goes wonky a little bit. So let's try this again. Uh-oh. You know what? I don't know why this happens, you guys, that this just kind of loses the internet access here. I mean, you can hear me, right, Warwick? I'm still on the internet, right?
Yes. Yes, I can.
Okay, that's good. Oh, here we go. All right, there we go. All right.
Service providers.
Yeah, I don't know what it is. So I want to show you what Azure Blob Storage looks like in the Azure Management Portal. So in your Azure Management Portal, if you wanted a new storage account, you would just click New right here. And then a window quickly comes up and it says, what do you want here? And I could say, I want storage. And it says, oh, do you want a storage account? Do you want to store blobs, files, tables, and queues? Yes, I do. And I'm not going to create one, but you can create one in just like a few minutes and it works just fine. But if I go to my dashboard, you'll see I already have one called Data Ike 1. Oh, it's not up here. Let me go to my All Resources and I'll show it to you. So that dashboard is just like shortcuts for things I popularly use. Here's Data Ike 1 right there. And when I bring it up, it says, oh, are you storing blobs, files, tables, queues? I can say I'm storing blobs. And now inside my blobs, I have a container. Remember, that was like the folder that I talked about earlier. And no blobs found, right? Okay, let's go back to code. So now, oh yeah, let's start that again. Oh, wait, I wanted to show you one more thing, and that is if I come back, I have something called access keys. And if I click on access keys, you can see key 1, please don't memorize that, and the endpoint, so it gives me a little connection string, right? My storage account name is Data Ike 1, here's my key. Okay. So if I come back here and step through, okay, so I'm going to create a storage account in code, which is my account name and my key gives me access to it. Now that I've got a storage account created, I'm going to check to make sure I've got a container. That's that folder I told you about. I'm calling mine demo container block blob. And it says, hey, if it doesn't exist, go ahead and create it. And now, upload a file. And what do I upload? I upload hello world.png up to my storage account. And if I click that, it uploads it. And then I say, hey, go into my container, go into that demo block blob, and list the blobs that are there for me. And it goes in and it says, oh, I see one. And which one is it? It's hello world.png. Here's the full URI. So I could take that full URI, copy it, put it in a browser, and it would display that image for me. So in the meantime, though, I can go back to the Azure Management Portal, right? And I can go to my blobs and my container, and now you can see, let's refresh that. Hello world.png is just sitting there. I click on it, and here's the full URI, and if I copy that, put it in my browser. Oh, maybe I haven't, I might have secured that. It might not be open for public access. There is a tool that Microsoft creates called the Azure Storage Manager. And you can see I add my account, and when I add my account, I just provide the account name and the key, just like normal. And then once I have that, I can open up either blobs or queues or tables. And in this case, if I open up my blobs and I click here, it's empty, but if I click refresh, now you can see hello world.png is up there, and I can download it if I use this little Azure Storage Explorer, and upload new files. It's just a way of like interacting with my blob storage account without writing all the code that you saw me write earlier. Okay, so that's blob storage. Let's move on. So now let's look at Azure Table Storage. This will go a lot faster because a lot of the things that you learned in blob storage will apply to table storage. It has the same scalability and redundancy. It has a very affordable price. It is very, very fast. It is a NoSQL key value pair solution. Now, when I typically tell DBAs that it's a key value pair, they think that it's just two columns, the key column and the value column. But that actually is not true. A key value pair is referencing how the data is retrieved out of Azure Table Storage. So in Azure Table Storage, you have to have the row key of the record you're looking for in order to retrieve the other columns of that row. And there could be like 5 columns or 10 columns or 100 columns, but you need to have the row key, you have to know it, in order to go get access to all the other columns in the Azure table. Now you might be asking yourself, well, why would I do that? I'll just use SQL instead. SQL is so much more, feature rich than Azure Table Storage. Well, the reason why we do this is because without the overhead of all the other things that SQL does, Azure Table Storage is lightning fast. And I'll give you an example of that. I wrote an application like 5 years ago, way before like SQL Azure. It used to be called SQL Azure, not Azure SQL Database. Right before SQL Azure had performance SLA like it does now. And I wrote this thing, and we were releasing, and we just didn't performance test it enough. So when the load came, Azure, SQL Azure was folding on us at about 60 transactions a second. It was folding on us. And we were actually denial of servicing attack ourselves, so we couldn't gain access to our database. So we panicked, and we called Microsoft and we asked them what to do, and they said, well, you should probably use Azure Table Storage instead. So we rewrote our data layer, we used Azure Table Storage, and we could not fold Azure Table Storage. We loaded it as much as we possibly could think of with all the different tools we could using our application, and we could never make it fold. So that's one example. We needed just raw performance, but what do you get for that? There are no indexes in Azure Table Storage, no check constraints, no foreign key constraints, no primary keys, no store procedures, no views, all of that in SQL you don't get. That means you're writing it yourself. So you might ask yourself, well, if I had to use Azure Table Storage and I had to get a record by somebody's birthday, what am I doing? Well, you're creating that index yourself. You're probably creating another table organized by birth date as the row key, and then another column or 2 columns might be the data you care about. So you might have 5 or 6 columns in there that you care about, or it might just be a pointer to the record that you actually care about. So that means that you're just by hand creating the indexes and you're keeping them updated and current and all that stuff. And well, no store procedures. So what are you doing? You're taking all that business logic and you're putting it in C# in your middle tier code. So what you learned about in Azure Blob Storage applies here. We have a storage account, Sally, and we have a table, in this case, customers table or wine photos table, and we have an entity, and those entities have columns like names and emails and photo IDs and things like that. Now, Azure Table Storage also introduces this concept of sharding. So sharding is basically, and they don't tell you the implementation, but it's basically controlling what server your records are on. So if we said we've got a bunch of movies that we're storing and we're going to keep all of our action movies on one server and all of our comedies on another and all of our dramas on even another. So what that means is if you're only interacting with action movies, you're not dealing with the contention or the load by everybody else that might be looking for comedy. So it's a way of having all of your servers kind of divide up the work and isolate the load from each other. And it's also a way of having 3 servers respond to your requests, so you can have requests that span multiple partitions, right? While you collect the data and hand it back to the user in your application. Microsoft does not charge you for this. You can shard as much as you want or as little as you want. It's all about the performance of your application. You're only charged for the storage space, not for the compute for Azure Table Storage. So the competitor to Azure Table Storage is Amazon DynamoDB Table Storage. That's also their key value pair. So how does it look in code? Well, let's go ahead and take a look. So we'll stop the app and we'll change table storage over as our startup project. And just so you know, in here I've got a model that this is my customer key, this is my customer entity. This is what's called a POCO, or a plain old C# object. This is the way data looks to a developer. Like they just write these POCOs that all have empty properties, like an email and a phone number and a last name that's a string and a first name is a string. In that case, that's my partition key and my row key. Okay. So now that you know that exists, why don't we go ahead and just launch this app. The first thing I do is I go get my storage account. How do I do that? Well, guess what? It's an account name and a key, just like you saw with Blob Storage. And once I have that, I can get a reference to my table. I called my table customer. It's right up here. It's this const right up here. This table name is customer. So I handed my table name customer. I get the table and I hand it back. Now once I have a table, now I can create a brand new customer. In this case, it's Sterling Archer with an email address and a phone number. And that now I'm in my POCO that I showed you earlier. And now I set my phone number. And now I just one line of code, insert or merge entity record. And I provide the table and I provide the record. So the table is the customer table and the record is the Sterling Archer guy that you saw me create, right? Now once that's created, it's this line right here, this on the table execute async, the merge operation is off of that customer that I handed in earlier. Now I've got an inserted customer and now I can do other things with it. Now, before I do something else with it, let's go to Azure Storage Manager. Here's my customer table. You watched me insert that record, and this is what I was showing you earlier. My table only has 4 columns, but it can have 5 or 10 or 20, a bunch of columns here. As long as I know the partition key and the row key, I can go get the correct record coming back to me. And that's Azure Table Storage. What do you guys think so far? Everybody's good?
Going well.
Going well. Okay, good. All right. So those are the first 2 products out of the way. Now we're going to move on to the third product, which is Azure DocumentDB. Now, when I talk to DBAs, and I say to DBAs, hey, we're going to store some data, and we're going to have this data and that data and this data, I could watch the DBA create the relational data model in their head, right? They're like, oh, this customer's table's over here, orders table's over here, they have this type of relationship, they're going to join on this key, right? You guys do this instinctively and it's very comfortable to you. But to most developers, particularly if they're developers under 30, that's not how they think of data. Software developers tend to think of data as a hierarchy. So they're more likely to use, DBAs and data consultants talk about relationships, like this will relate to that, will relate to that. But developers talk about containing. They'll say like, oh, well, if I have a classroom, that will contain students and a teacher and books and things like that, right? If I have a library, that'll contain books and librarians and desks and tables and a card catalog, right? So they're always talking about what contains what. And to them, data is a natural hierarchy. So, and we know this because for a really long time, the lingua franca for data exchange on the internet was XML. But XML is a very verbose language, and it's kind of picky. If you make a mistake in the syntax, or the syntax can be complicated, it's hard to read. And so almost as one, web developers all decided that they hated XML and they never wanted to use it again. And so Yahoo created a language for data exchange that they called JSON. And they said, really, if you take out all the ceremony of XML, at its core, all we really care about is the field name, the field value, the field data type, and the hierarchy. That's all we care about. So if you look at this, my slide right here, you're seeing JSON. And you're seeing the natural hierarchy of it. Like this is a John Smith record. And under here we have phone numbers. And we have a home phone and office phone. This is an array. This square bracket represents an array. Oh, John Smith doesn't have any children. He has an empty array for children and no spouse, right? He is not in a partnership. So that's the way data looks to a developer. Very simple, very hierarchical. Now, if you tell a developer, I want you to store this in SQL, to you guys, this is really no big deal. You don't care. I mean, it's a no-brainer for you. But to a developer, it's very complicated because they've got to think about what they call shredding, where they're going to shred this JSON into a table structure. And they have to know like what fields go into what table. And they have to, order is important, right? They have to know that you have to update the customers table first in order to get a customer ID. And then once we go to the orders table, we can put the customer ID in the orders table to create the relationship. And if they make a mistake there, they will get errors like, hey, foreign key doesn't exist, or some errors they don't even understand, right? And updating them should be done in order, and deleting them should be done in an order, right? And they end up writing all this code to make sure they're doing all this work in the right order in the right table, and they look at that and they think, well, that code is plumbing code to me. So they end up replacing that plumbing code with like an ORM, an object relational mapper. That's what an object relational mapper is. It takes the hierarchy of JSON or an object model and the relational nature of a SQL database, and it maps them some way so that developers don't have to write all of that plumbing code. And they have to get good at it, so they're going to use Entity Framework or in Hibernate or Dapper, and they're going to have to get really good at this ORM so that they can figure out what it's doing so they don't have to write all that code that they're trying to avoid, right? Well, this is what DocumentDB does. DocumentDB allows them to read and write that hierarchy as one operation with no assembly, no deassembly, no shredding. They can just save like they're saving a Word document, open it up like they're opening a Word document, and they can do it all really easily in code without any third party or without writing all that code by hand. Now, DocumentDB also has a SQL-like syntax that you can use to query DocumentDB, but remember that JSON is hierarchical, so what you're basically doing when you write SQL to interact with DocumentDB is you're flattening the hierarchical nature of the JSON so that you can use it someplace like Excel or something like that. It's not perfect, but it's pretty good, and it's getting better all the time. The competitors to DocumentDB are MongoDB and Amazon DynamoDB. Now, hey Ike, you told me about DynamoDB already when you talked about table storage. That's true, but DynamoDB has a different component called document storage that competes with DocumentDB. Okay, so let's look at that. Let's look at it in code. So I'll go ahead and stop my project here, and I'll go into my DocDB demo. Okay, before I go in the DocDB demo, I want you to look at the POCOs here for DocDB. I'm creating an online conference. And just to prove that I'm not pre-baking the turkey, by the way, let me go back to my dashboard. I have a DocumentDB database called Conferences. And inside my DocumentDB database, I have a collection. A collection is similar to a table. And in my case, my collection is fall conferences. So I'm going to keep documents that are similar in function or form in the same collection. And these collections are my scale unit. I could have 5, 10 different collections if I wanted, right? But I pay for each collection. So in my case, I just have one collection, fall conferences. And if I open up Data Explorer, you can see if I open up my database, I open up my collection, I go to documents, there are no documents here. This is empty, right? Okay. Now that you can see that, I'm going to go back to code and show you for my conferences, conferences have sessions, sessions have attendees, and they have speakers. So I create a conference, and you can see kind of the hierarchy. Here's an attendee, that's a person, object, people have names and employers, and then I have speakers, and then I wire it all up. I say, okay, here's a brand new session with this speaker and these attendees. Here's another session with this speaker and these attendees. Here's another session with this speaker. You can see the hierarchy just sitting here in the code, right? Okay, so now let's step through it. So, step into my code here. Okay, first thing I need is a client. What do I do with how do I create a client? Well, a client has an endpoint, and it has a key, just like storage, just like a blob storage and just like table storage. So that's what I just did there. And then I create a database if it exists. If it doesn't exist, I create it. And if it does, I just return it. And then once I've got the database, then I go get a collection. And in this case, my collection is called Fall Conferences, right? So I open up the database, and I say, oh, you've already got that collection. So I just hand that collection back. And now that you've seen me go get the storage account, with that endpoint and key, go get the database, go get the collection. Now let's do the real work, which is add some documents, right? So in this case, I'm going to go ahead and create a conference, and you saw me go through this code already. So this is if I hover over this, you can kind of see, look at, there's a session, and this session has attendees, and those attendees are, names and employers, right? So you can see the hierarchy as I drilled through there. So now that I've got the conference there, now let's save it. And the way I save it is just this client has a document link and for my collection. So that's the URI for the collection. And then it has a document object. In this case, that's that same POCO that you saw me create, right? So I'm saying, take that POCO, all that hierarchy data, and just save it for me. I just want you to, just one click, just save it real quick. And it saves it. And then it goes to the next one. Now, before I go to the next one, if I come here and I just refresh, come on, refresh, hang on. Let's go back into it. Conferences, collection, documents, there it is. And if I click on it, that's the JSON that it saved for me. All right there, ready for me to use. I didn't write any SQL code. I didn't have to do anything special. I just did one line of code and it saved it for me. Okay, I'm going to do that same thing 2 more times. All right, so if I come back here and you can see all 3 right here. There's conference 1, there's conference 2, there's conference 3. And in this little, I'm in Chrome, right? This is just my DocumentDB Data Explorer. I can say, I can edit it in line, right? I can say, hey, Warwick, and update it. That's me changing stuff about this. I could edit my JSON however I wanted to in line using this tool, right? So I come back here, let's query it. So I'll step into my query. And look, we know what I'm going to do here, right? We know I'm going to go get a client, go get a database, go get a collection. And now let's go query. We're actually doing a read. And how do I read it? Well, if you have development experience, this is comfortable to you. I'm just reading it with link. So this is a link statement that looks a lot like SQL, but we use link everywhere. We use link when dealing with XML, when dealing with objects, when dealing with Entity Framework. Link to SQL exists. We use link all over the place. So this says, give me everything. This is basically a select star from the conferences database and the fall conferences collection. Just give me it all. And then once I do that, it says, okay, just loop through it for each and tell me all the conferences that you find. And it's going to find 3, and it's going to write it to the console. And there it is. It found 3, and if I go to the console, you can see, oh, look, hi, Warwick. See, I'm doing this right in front of you, right? I saved those 3 conferences, I edited in line, and I brought them all back using one link query. All of this code is what got executed just now. So that brought me back all of those records. And oh, I'm out of the loop now. But with all the properties bound and everything, we could do it again. Watch. So this is just a real quick read key. We have a different type of link. And if we were developers, you would think that was really cool because we can use inline link here. And now it's just going to go through and look inline. And look, here's a conference name. But if I hover over conference, that hierarchical nature of the conference that you saw earlier, right? Look at sessions and attendees and their name and employer, right? All populated for me, all by the SDK. I didn't write any code to do this, right? So we go through our 3. And then there's one other way of doing this. And look, what's that? That looks like actual SQL instead of just link, right? So this is like, hey, give it to me where start date equals this specific start date. And it goes and it finds it, or where it's greater than that specific start date. And it finds that there are 3 of them that are greater than that specific start date. And I could show you a bunch of other stuff too. I could show you updating and deleting and how easy that is. But one thing I did want to kind of show you the code for, although I'm not going to step through it, is this. And look, I can create stored procedures. This is a new stored procedure. And instead of being in T-SQL, this stored procedure is in JavaScript. So this is the strength of DocumentDB. I could use JavaScript to create a web application with CSS and HTML5. And then I can use JavaScript to create a middle tier web services with Node.js. And I can use JavaScript to create stored procedures and triggers and user-defined functions in DocumentDB. So as a developer, I just have to know JavaScript really well, and I can use JavaScript end-to-end in my application without knowing any other languages. There's an awful lot of power to that. All my stored procedures are in JavaScript. That's pretty cool, I think. So that's DocumentDB. Very good for developers. Now, you might think, well, does that mean we don't want to use SQL anymore? Like, why would we use DocumentDB? DocumentDB looks so great. Well, here's the problem. DocumentDB is really great if all of your data access is going to be from one application. So if I'm creating a video game, or I'm creating like Tinder or some mobile app, DocumentDB is a fantastic place for this. Fantastic place. But if I need to like do a lot of enterprise reporting, if I'm in an enterprise with a database where a lot of applications are sharing the data, if I don't have a scale problem where I don't have like 100,000 users using it, but I have like 10 users using it or 20, or if I just have a lot of corporate knowledge wrapped around SQL. I mean, SQL is still very scalable. It's still very powerful. It has a lot of purposes, and it's a great platform for writing applications if the data is going to be used 20 different ways, right? And data integrity is really important, right? DocumentDB doesn't have any native data integrity facilities, right? That's all done in the application itself. It's not done in DocumentDB. And that's DocumentDB. Now we're going to move on to SQL. How are we doing so far?
We're tracking along really nicely.
Okay, good. So if you take a look at this diagram at the far lower left of the diagram, this is your on-premise SQL servers, right? Where you have like bare metal, you have raw iron, you have SQL Server with memory and hard disk and network cards, and you own it, and it sits it, you power it, you put it under some type of anti-fire or fire suppressant facility, I'll cable it, all that stuff, right? And then if you go up from there where you virtualize it, that means that you have one bare metal server or one, physical server, and then you install different SQL servers on the physical server, and they share a physical server with each other. So, but you still are managing it, you're just managing it virtualized. Well, Azure has a service called an Azure Virtual Machine. And that is the same thing, except Microsoft owns the physical hardware. They own the hard drives and the network cards and the, everything. But you have a virtual machine where you own the operating system and you own SQL Server, which means you have to virus protect it, you have to patch it, you have to upgrade it, you have to manage all of that. But if a network card fails, you'll never know. That gets taken care of behind the scenes. And you don't power it, and you don't worry about the fire suppressant system. That's all done for you in Azure. Right above that is a platform as a service offering, and that's Azure SQL Database. And Azure SQL Database, it's a version of SQL all on its own. It progresses faster than SQL Server on-premise. So Azure SQL Database, you don't know the operating system it's running on. You don't know the version of SQL it's running on. You just know like one day you walk in and you have new features because they upgraded it for you automatically, and you just pay for exactly for what you use. So that's platform as a service. That's where Azure takes care of everything for you. You just focus on your data, your schema, your application, and providing value to your customers or your users, right? So if we talk about Azure SQL Database, that platform as a service offering, it's backed up for you. All the data is backed up for you. It just starts backing up as soon as you're using it, and you have access to a point-in-time restore. So if at 12 p.m. noon you delete all your customers, at 11:45 you can restore your backups all the way to 11:45, and you won't lose that much data, maybe 15 minutes of data, and you'll have all your customers available to you. It can be geo-redundant. You can store data in multiple data centers, and it will remain consistent with each other. It's scalable both in performance and data size. You can have up to 1 terabyte of data there. It's not feature complete with an on-premise SQL Server, but it's pretty darn close. It has all the really main features that you would use. For any Azure SQL database, when you create the database, you automatically get 3 physical copies of your database. You get a primary and you get secondaries. If the primary ever goes down, the secondary takes over automatically. That's all done automatically for you. All you did was say, hey, create a database, and boom, you're using it automatically, right? Here's a URL for the unsupported features. My slides are up on my website, ikeellis.com. You can go to slideshare.net and see all my slides, or go to my blog and you can see my slides there. You can also scale up. So they call it a database throughput unit, or a DTU. And if you have 10 DTUs, then you can get an S0. But if you need 100 DTUs, you can get an S3. And it just kind of scales up. An S0 is $15 a month, but an S3, which is 10 times faster, is also 10 times more expensive. And you can have up to 250 gigs of database size. Now P11, you could DTUs are 1,750, and the price is $9.41 an hour, or roughly $7,000 a month. So you can have something that is very high performing, but it's also rather expensive. And the competitor to Azure SQL Database is Amazon RDS. But Amazon RDS has a lot of things. You can run SQL Server with Amazon RDS, but you can also run Oracle and Postgres and MySQL and Aurora DB. That's one thing that Amazon can do that at the moment Azure SQL Database can't do, but that might change in the future. Who knows? I don't know. Or maybe, So I think we're going to skip the demo for that right now and instead talk about Azure SQL Server in a VM. This is where you own the SQL Server, you own the operating system, you're just using, it's an infrastructure as a service offering where you're just using Azure's hardware. So that means you manage the backups, you manage fault tolerance, you manage the disk space, you manage patching, right? You just don't manage hardware failure, network infrastructure, things like that. So always on availability groups is available in Azure. And as a matter of fact, you can do a hybrid. You can have always on availability groups on premise where you have a secondary in Azure. So an Azure VM is participating in your always on architecture, which is pretty powerful. So that means if anything happens to your data center, Azure can take over. Maybe it's a little slower because you didn't pay for enough, or I don't know what, but it is available to you. So here's some performance considerations. Use premium storage because it's much, much faster. Use a VM size of a DS3 or higher for SQL Enterprise. 2 P30 disks, one for log and one for data files and TempDB. Keep your storage account and your VM in the same region so you don't have to deal with network latency. On the Azure storage account, disable geo-redundant storage so that you don't have the overhead of that in your virtual machine. And then avoid using your OS disks or temp disks for database storage. Make sure your database storage is on like your L drive or your T drive or your S drive, which is a whole other disk, which is guaranteed to be persistent. Your C drive in an Azure VM is not guaranteed to be persistent. So don't put data files on there. And like I said, we can use always on availability groups. We can use mirroring and log shipping. We can mix it with on-premise. Very, very, very powerful, very flexible. And then the competitor to Azure virtual machines is Amazon EC2. And chances are, I told you about Amazon S3 and I told you about Amazon EC2. Those are by far the two most popular services in Amazon. And that's it. Those are transactional SQL servers where you have applications that you've written that are OLTP applications, online transaction processing applications, interacting with either Azure SQL in a VM that is totally SQL Server on-premise, like it's feature complete, or Azure SQL Database, which is not necessarily feature complete, but like it doesn't have SQL Server Agent, for instance. A couple other things. It doesn't have the CLR. It's another thing it doesn't have. So, but it manages backups and fault tolerance, and all that's done for you without you having to set it up. And it has some cool, like you can just check a box and have TDE, transparent data encryption, and check a box and get intrusion detection. So you get really cool features without really paying a lot of money for it. So now we're switching topics and we're moving over to Azure SQL Data Warehouse. Azure SQL Data Warehouse is an analytic engine, and it's used for straight querying and ETL and data movement and asking questions like, if I have, 10 months of data, what was my best sales day per month for the last 10 months, right? You could ask questions like that with Azure SQL Data Warehouse. So Azure SQL Data Warehouse is not for transactions. It is only for analytics, only for querying. And it is what's called a massively parallel processing system. What that means is that we have multiple servers hosting your single database, and those servers each have a portion of your data. It's called a shard. So they just each one of those nodes just has one little shard of your data. And then when you ask questions like, what's my best sales day per month, Azure SQL Data Warehouse goes and divides up your question and requests that of every server, each server per month, and then each server per month answers, and then Azure SQL Data Warehouse collects all that data into one answer for you so that you can see it, right? Now there's overhead doing that and dividing up the data to the individual nodes and then in collecting the answers back to you. And that overhead means that Azure SQL Data Warehouse sometimes is not hyper responsive. Sometimes it doesn't answer back in a millisecond the way like an on-premise SQL Server would or Azure SQL Database would. But it's consistent, which means it will always answer you in the same amount of time, and that amount of time will be predictable. So if your data grows, like you grow up to a petabyte of data, then you just add more nodes to Azure SQL Data Warehouse, and you'll still get the same consistent results as you add more nodes to it. Now, the Azure SQL Data Warehouse scales compute separately from the data, which means you can specify that on the compute side you have 5 nodes or 10 nodes or whatever you have, right? And then you can pause Azure SQL Data Warehouse and nothing bad happens to your data. Your data just stays there where it is. But you stop paying for Azure SQL Data Warehouse. Now it's not charging you because you paused it. And then if you go back and say, hey, I want to use that data again, you just hit play. And I can show you this, by the way. This is right here. So if I go back to my dashboard and I go, this is my Azure SQL Data Warehouse, you will see that it's playing right here, right? And if I click pause, it'll stop billing me. That's a lot different than Amazon Redshift, which is its main competitor. Redshift scales compute and storage together. And as long as you want access to the data, you have to keep Redshift running, so it's going to bill you the whole time, right? Okay. So Azure SQL Data Warehouse supports 32 concurrent queries, which if you're an OLTP developer, that doesn't sound like very much, but actually that's a lot. For analytics, that's a lot. And it's used for fanning out those queries across multiple machines. Performance is predictable, not used for OLTP, so we covered all that already. It uses a DWU, or a data warehouse unit, for scaling. It's done in increments of 100. I would start as small as you can and scale up as you need because it can be very, very expensive. So I can show you that too. If I go back to, if I go back to my, all right, so what you'll see is I can scale, and the scale comes up and it says, what do you want? You can see the price over here, 100. Oh, it's loading the prices. And I could just scale all the way up if I wanted to. Now, if I do 400, it's $6 an hour. If I do 1,000, it's $15 an hour. Or I go all the way back down to 100, and it's $1.50 an hour. So that's expensive. That's not cheap. That you got to be careful with the slider bar, right? Or you're going to get some unexpected bills. So just be aware of that. In Azure SQL Data Warehouse, we partition our data. We can either do it like a hash value of a single column, or we could just distribute data evenly but randomly across all the servers. Typically what we do is we do a hash value of single column, and that column exists in all the tables that we want to partition, so that we're keeping all the tables and their join tables on the same node together, so we can query them all together without spanning a whole bunch of tables. Now, it's just the great thing about Azure SQL Data Warehouse is that it's just Transact SQL that you're using. In fact, it's just SSMS. So if I go back to my demo here, this is SSMS. This thing right here, that's Azure SQL Data Warehouse. This database I have here. And I have a whole bunch of tables. I have the database log table, the DIM account table, the DIM customer table. And right here, if I run this query, that's Azure SQL Data Warehouse just responded with 18,000 records right here, up here at the top corner, across multiple nodes if necessary. And it did it in SQL Server Management Studio. So I can use SSMS to interact with Azure SQL Data Warehouse, which I think is pretty powerful. Okay. But there's a cost. There's a whole bunch of unsupported data types like geometry and any CLR type and the table type and varchar max, XML. You can't use any of those. You also, no primary keys, no foreign keys, no check constraints, no unique constraints. You know, you're looking at, Ike, why would we use this if we don't have access to all these cool features? Well, the reality is these things were getting in the way of partitioning and distributing the data to multiple nodes, which is why we don't have any unique indexes. Now, but the Azure DW team, they're aware of this, and they are addressing it. I would stay tuned to recent announcements to see what they're doing about this. I think you'll find that some of these limitations are going away. And like I said earlier, the main competitor to Azure SQL Data Warehouse is Redshift, Amazon Redshift. And you just saw me use SSMS with it. So now, let's talk about our last product. It is Data Lake. A data lake is a generic data architecture term that says this. So if you guys might have created data warehouses in the past, right? Like a data mart. And when I say things like a data mart, you know what that is. You know that it's clean data, right? How did it get cleaned? It got cleaned in ETL, didn't it? Like somebody wrote an SSIS package, they cleaned the data and they put it into the data mart, right? You're thinking like it's relatively small, right? Data warehouses can be big. Data marts can be big. But there are a lot of data marts out there that are like 5 gigs, 10 gigs, 20 gigs, right? If I said I had a 500 gig data warehouse, that's a big data warehouse. And if I said I had like a 5 terabyte data warehouse, now people are starting to feel some pain there, right? Things are a little slow, and even basic things are very, very slow, right? But they tend to be on the smaller side. They don't tend to be petabytes, right? So a data lake says this: if we have so much data that to move it over a network card would be painful, then why not just leave the data in place where it is, and we'll clean it in place. And so where a data mart might be perfect clean data for consumption, a data lake might be like the dirty fishing hole pond behind your house, right? The water's there, but you might not want to drink it without like doing something with it first. So you store all your data in this one central repository, and then we clean it after the fact. Now, I'm doing a Pluralsight course on Azure Data Lake Analytics and Azure Data Lake Store, so I can only go very basic into this right now, but just understand that that data lake, that generic architecture term of a data lake is exactly what Azure Data Lake is. It's just a kind of a junk drawer for your data, but that junk drawer never runs out of room. So you can just store a whole ton of data in it, and it's built, so these two products, by the way, Azure Data Lake Store exposes a Hadoop distributed file system API. And what that means is you could store a ton of data in ADLS, and you can consume it using very popular Hadoop frameworks like Pig and Hive and Yarn and Storm and Kafka can all look at data in ADLA. The other product for Azure Data Lake is Azure Data Lake Analytics. It's built on Hadoop Yarn, but it exposes a very unique interface that only it has called USQL. USQL is a combination of SQL, the language that you know, and C#. And it takes the best of both of those elements and it uses them together. Now you might think, Ike, that sounds kind of ridiculous. What do you mean by that? Well, let me show you real quick. So get out of my slide. And I'm going to come here. And you know what? While I'm here and I'm thinking about it, I'm going to pause this because I don't want to get billed for this anymore. Say yes, pause it, please. That's me pausing my data warehouse so I don't bill it. So I come back here and you'll see Data Lake Analytics. And I can look at all of my jobs here. So let me view all the jobs that I've run in the past. And I'm just going to duplicate this job right here so you can see it. Okay, so one thing right away that's different about Data Lake that is way different than Azure SQL Data Warehouse is Azure SQL Data Warehouse had me choose how many nodes would be processing my request when I created Azure SQL Data Warehouse. And I can scale up and I can scale down. But what I'm doing when I scale is I'm scaling for all the entire workload in Azure SQL Data Warehouse. In Data Lake, I'm scaling by the job. So that means that if I have 10 jobs running at the same time, each job can have a different parallelism attribute called AUs. So right now I'm saying for this job, I only want to run it with one node at 3 cents a minute. If I say, no, I want 2, 3 nodes, 4 nodes, see, 3 nodes, 10 cents a minute. What's 10? 10 nodes, 33 cents a minute. So basically it's 3 cents per node per minute. And I can say, oh, what is this? This stuff right here is just, it's just USQL. And what I'm doing here is I'm going to Azure Data Lake Store, and I'm going into my IIS logs folder, and I'm going to 2008-01, a web log, and I'm putting a schema over it. So the data is in place, right? The log is just sitting there in Azure Data Lake Store doing nothing, and I'm getting charged very little for it. And then what I'm doing is I'm saying, take that log file, and I want to start using it, but before I use it, put some columns over it and make those columns have data types. And then once you've done that, I want you to give me the number of hits per date and the total number of bytes and the total server bytes and the total number of client bytes. And then I want you to take that and store it in the daily sales summary variable and then output that daily sales summary variable as a CSV in my output folder in Azure Data Lake Store. So if I submit the job, this just cost me 3 cents, and now it's running, and it's just going through here. It takes about 30 seconds. But you can see it's preparing the job. While it's doing this, I want to talk to you about something. So you guys are DBAs, and you guys are I know when you guys create SQL, right, we all write SQL, and we go look at the physical execution plan. Sometimes the SQL optimizer makes the decision for us. What it will do is it will say, I'm going to parallelize the workload for you automatically. And then it's going to spread your work across multiple cores on the SQL server. And then it's going to get finished, and then it's going to reassemble the work and then sort it or something like that, and then hand you the results back, right? And DBAs say all the time, like, oh, I was expecting a serial plan and I got a parallel plan. Ah, why did it do that? Or I thought it would parallelize it and it serialized it. Oh, why did it do that, right? And the frustration is that the optimizer, is making decisions for you, right? C# doesn't work that way. In C#, if I parallelize something, I make a deliberate decision to parallelize it. And I have to manage the threads myself somehow with the task parallel library, or I have to do some locking or syncing code. I have to write a lot of code in C# in order to parallelize my workload. So when a C# developer goes and looks at what SQL's doing, it looks like magic. They're like, oh, it'll parallelize for you automatically and you didn't have to tell it to? That's amazing. I love that it does that, right? Well, I'm telling you the difference there because that's what UseSQL is. UseSQL says, I'm going to let you use C# in your SQL scripts, and I'm going to parallelize it for you automatically. It's creating these things called vertexes. Now, my job, it didn't parallelize. It just was one vertex. But if it had 10 here, that would tell me that this might be a good candidate for adding more AUs to my workload to see if I can get the job to run faster or in less time or maybe cheaper. Anyway, so that is the engine parallelizing it and letting me use C# at the same time without having to write a whole bunch of parallel code. Now I also have this output folder right here, and this is pulling the CSV directly out of Azure Data Lake Store. And it's just going to show it to me. And guess what? It's going to show me the columns that I asked for. Those 4 columns that I had before. On 1/1/2008, you had 2004 requests, and this was your, client and server, total network bandwidth used. Okay. So what are the competitors to Azure Data Lake? It's really just Hadoop is, a cloud version of Hadoop. Amazon, for their data lakes, they use S3, and they use Hadoop as a service over it. So we can also use MongoDB in the cloud, Postgres, Redis Cache, MySQL, Oracle. They're all fully supported in Azure, by the way. So if you use MongoDB in Azure, you can call Microsoft, and they will not hand your case off to somebody else. They will solve your problem with Mongo because you're using Mongo as an IaaS play and as infrastructure as a service. And that's it. Hopefully, I calmed your choices down a little bit and you understand why we use specific things and you know a little bit more about why we store data in specific places. And I hope you enjoyed the last, hour and 10 minutes with me. I appreciate your time.
Thanks, Ike. Thanks, everybody, for joining us in this month's session. Ike, we do have one question for you. The scripts that you've used during the session, are they going to be made available to the attendees?
That's a great question. I need to strip out all my keys before I can put them up there. So in the next couple of days, I'll strip them out and I'll put them up on GitHub for you. And I'll put a link, I'll tweet it out or I'll put a link on my website. Excellent.
Thank you for that. Does anybody else have any more questions? I know we went a little over today, but it was a great session by Ike. And if we haven't got any more questions coming through, then we'll call it a day. And I look forward to seeing everybody next month. Next month we have, what have we got? We've got how to plan, design, and implement a HADR solution, taking you on a journey. So make sure that you register for next month's session, and I look forward to seeing you all same time next month. Thanks, everybody. Goodbye.
Thanks, guys.